Imagine a campfire on a cold night. Too close you burn, too far you freeze. There's a perfect spot where the warmth feels just right. In space, stars are like campfires, and around each is a just right region, the habitable zone or Goldilocks zone. This is where a planet isn't too hot or too cold, but just right for liquid water. Planets too close to their star, like Mercury, are scorched, too far, like Neptune, and they're frozen. The habitable zone is the sweet spot where water could flow as a liquid, but not all habitable zones are the same. Big, hot stars have wide, distant zones. Small, cool stars have narrow, close-in ones. Think of the difference between a bonfire and a candle. You have to huddle closer to the candle for warmth. The type of star determines where this special zone lies. This simple idea guides our search for life. We look for planets in the habitable zone. It's our first filter as we scan billions of stars, searching for other Earths. The question is simple: where could liquid water exist? The habitable zone points us to the most promising places in the galaxy. It's the first clue in the search for life beyond Earth, and it's where our cosmic detective story begins. Why focus on liquid water? Because on Earth, wherever there's water, there's life. From boiling hot springs to Antarctic ice, life thrives where water flows. Water is the universal solvent, dissolving nutrients and fueling the chemistry of life. It's the lubricant for life's machinery, allowing molecules to interact and build complexity. Without liquid water, life's chemistry grinds to a halt. So when we search for life elsewhere, we're really searching for the potential for this chemistry, meaning we're searching for water. The universe is full of water's ingredients, hydrogen and oxygen, but liquid water needs the right conditions. That's why the Goldilocks zone matters. It's where water can stay liquid for billions of years, giving life a chance to emerge. When telescopes find a planet in the habitable zone, it's not a guarantee of life, or even water, but it's a possibility. It's a cosmic invitation. This world might have oceans, rain, or rivers. The search for habitable worlds is really a search for these rare oases, pale blue dots in the vastness of space. Each discovery brings us closer to answering the question, are we alone? Water is the thread that ties all life together, and so our search for life is, at its heart, a search for water. For most of history, we only knew the planets in our solar system. Now we know our sun is just one of billions of stars, most with planets, exoplanets, of their own. Our galaxy is teeming with worlds, some right next door. Take Proxima Centauri b, orbiting the closest star to our sun, just 4 light-years away. Discovered in 2016, Proxima b sits in its star's habitable zone, and is a rocky world a bit larger than Earth. It could have liquid water, though its red dwarf star is violent, blasting flares that could strip away an atmosphere. Proxima b is tidally locked, one side in perpetual day, the other in endless night. But a thick atmosphere might create a habitable twilight band. And it's just one example. We found thousands of exoplanets. The TRAPPIST-1 system has 7 Earth-sized planets, at least 3 in the habitable zone. Kepler 186f is another Earth-sized world, 500 light-years away, in its star's habitable zone. Each discovery tells us planets like ours are common, not rare. We're just beginning to map our galactic neighborhood. The universe is more generous with worlds than we ever imagined. Every new planet is another piece of the puzzle, and each one brings us closer to finding another Earth. How do we find distant planets? We can't just look and see them, their stars outshine them by billions of times. Astronomers became cosmic detectives, watching stars for clues. The transit method is key. If a planet passes in front of its star, the star's light dims slightly. A tiny regular shadow. Telescopes like Kepler watch thousands of stars looking for these dips in brightness. Another method is the wobble or radial velocity technique. As a planet tugs on its star, the star wobbles, shifting its light's color. This Doppler effect reveals hidden planets. The transit method tells us a planet's size, the wobble method, its mass. With both we can calculate density, rocky like Earth or gaseous like Jupiter. By studying starlight passing through a planet's atmosphere during a transit, we can search for chemical fingerprints, water vapor, oxygen, methane. These are biosignatures, possible signs of life. Each detection brings us closer to understanding these distant worlds. Our tools are getting better, and so are our chances. The search is on. We have a map, the habitable zone. We have a key ingredient, water. And we have the tools to find distant worlds. But what makes a planet truly habitable? It needs the right size to hold an atmosphere, a stable orbit, and a protective magnetic field. The atmosphere must be just right, not too thick, not too thin, to trap heat and support life. We look for signs of biological activity like oxygen, which on Earth is produced by life. Every time we search the sky, we're part of a profound quest to find out if we're alone. The search for life is about understanding our place in the universe. Are we a cosmic fluke, or is life common wherever conditions are right? Even finding simple life elsewhere would be a monumental discovery. This search inspires us, pushes our technology, and connects us to the cosmos. We are stardust, part of a grand story. The universe may be silent, but we're determined to find answers. The search continues,